Alright, time for another draftphysics.com, debatephysics.com also. Okay, so another video in this series of how much do I have to pay a physicist. And it's literally really a question, I would like a physicist to tell me how much I have to pay them, okay, like to be interested enough to counter my arguments. Now, my arguments are supposed to be so bad that it should be no work at all to debunk me or prove me wrong. So it really shouldn't be asking much. But for a physicist with a reputation to uphold, I'm willing to pay whatever it takes almost. Whatever silly number you can make up. I'm that desperate, okay, to put a physicist, to make them man up and argue an actual position make an actual statement regarding their confidence in the kinetic energy theory. So again, I could just say the words 25 times the fuel to go 5 times as fast. It doesn't happen anywhere. It's not the truth. It's not real physics. And all of these different experiments demonstrate that, yes, there's a flaw in their reasoning and thinking to think that the mechanics are that simple. Now, maybe when you get inside of atoms and you're talking about energy reflecting inside of something, it might matter how fast something's going in terms of how often it has an interaction with something. But it certainly doesn't make any difference in these real world mechanical things bumping into other things circumstances. So anyway, so I began this lever stuff with this simple mechanical lever. I just made a floating balance, okay, and just demonstrated that a 4 mass at one distance obeys the law of the lever, and a 1 mass at 4 distances will balance the 4 mass at one distance, and it'll oscillate perfectly. And I have explained in previous videos that it's really just the mass of the lever that switches sides, a little bit of mass, and that's why it oscillates very slowly. Nothing's moving at any kind of gravitational free fall rate. Everything's moving much slower. But the absolute fact is that on both sides you have its same momentum. You have a 4 mass moving 1 velocity and a 1 mass moving 4 velocity. And momentum is conserved perfectly, and it makes rational sense. Now, kinetic energy says there's twice the energy here that there is here. And obviously it couldn't oscillate 100 times if that were true. And there'd be no mechanism to create that extra energy on one side and the less energy on the other, momentum. So it clearly demonstrates that, one is right, one is wrong, I would argue. Now, another experiment that's been done a couple of times was creating a launcher, what could be called a lever launcher with a spring. And the basic idea is you're going to create the same motion in the lever, so it's going to consume out of the experiment the same amount of energy. So you can negate the weight of the lever and the energy it consumes, because the lever is going to move identically to push a 2 mass, okay, at 1 velocity, and presumably a 1 mass at 2 velocity. Now, the frame rates came out pretty close to that, within the margin of error. Obviously, this could have been a 20 and this could have been a 10, fairly easy. And but it's way short of what they claim to be the kinetic energy result, the prediction of kinetic energy, which is 1.4. So the numbers aren't anywhere near the kinetic energy being correct. So it's pretty good evidence. And the fact that these experiments haven't been done by conventional physics, so physics hasn't done this. Well, it sort of has done that one anyway, but it hasn't done anything like this. And certainly this basic idea of you put a 2 mass in with a velocity, and their claim is, this is what Steve Mould claimed in his million-view video, that all you get back out is a 1 mass going 1.4. Now, obviously this experiment contradicts that, but logic also contradicts it, because it doesn't conserve momentum then. So if you put, 1 momentum in, 2 momentums in and you only get 1.4 momentums out, something's wrong somewhere. And clearly the formula kind of dictates this, so there's been some argument about springs and how springs store energy. Physicists actually arguing that you need 4 compressions of a spring, or 4 springs compressed, to move something twice as fast. And of course, I don't think that's anyone's life experience. But again, we don't have these tests. We can't just find a physics video that tests what you really do get. And the fact is that springs do lose a little bit of their effectiveness, their efficiency, with velocity. So the faster you push something with a spring, the less of the spring's energy will actually go into the object. But anyway, it's still nothing like 1.4. It's something like 1.8. Okay, not 1.4. So it's pretty clear demonstration. So Steve Mould made this argument, which can't be reversed. That is, if you take a 1 mass going 1.4 the velocity, you're certainly not going to get a 2 mass going 1 velocity. I think, again, everybody's life experience says you can't take less momentum and make more momentum, because effectively momentum does do work in the real world. It does crush cars. It does all kinds of things in the real world. And you can't make free momentum. And it's just a fact. Alright, so I'll pause there and see if I have anything else I need to add. Alright, so I will post a pinned comment where I'll put the link to this playlist that currently has 12 videos in it, where I'm quite desperate to get a physicist to respond. And I'll also put a link to a Google search result that should pull up all of the lever paradox videos. That is, that was what Steve Mould titled his video. And the fact you'll see is that nobody, just about, made any responses. And the only 2 besides me were by people defending this nonsense, frankly, this thing that doesn't happen. And the rest are, the 90 videos I made, or whatever the number was. And just clearly demonstrating physics needs to do these experiments and tease the truth out. Obviously, in this experiment, the lever will consume some of the energy. So you can have an expectation that even if you put a 2 mass going 1 velocity on one side and you have a 2 mass at the same distance on the other side, that you'll lose a little bit to the whatever the weight is of your lever, but nothing like 1.4. No chance. And again, their argument is that if I doubled this weight, I'm going to get 1.7. It's just kinetic energy. The squared velocity just means that term just destroys any capacity for there to be any sensible law of the lever. The law of the lever is 2,000 years old, and they're saying it doesn't really work. Now, pulleys work. They'll pretty much claim, but that's also part of this argument, is the contention that somehow pulleys do work, but somehow levers don't. And both of them have to do the same thing. They both have to follow the same rule. So it's either the 1.4 rule or the 2.0 rule, but there is no switching rules. You can't have a different rule for a pulley and then a different rule for a lever, because it's all basically making the same argument. Twice the velocity is what you're getting for cutting the mass in half, and that's the results. Momentum works. Kinetic energy is a fable. I think that's enough. Till the next time and such.